You wake up. The air is already hot. It is dawn on the African savanna. You stretch your legs. You are preparing for a long day. You will walk for miles. You will track animals. You will forage for roots. You will sweat. Your body is a biological machine. It is perfectly engineered for this specific environment. It is built to shed heat. But your brain is fragile. It sits inside your dark skull like a delicate, overheating engine. It demands constant protection. If it gets too hot, you die. Look at your arms. They are mostly bare. Look at your legs. They are smooth. Your skin is exposed to the wind. Now reach up. Feel the top of your head. There is a dense canopy of protein growing from your scalp. Why is it there? Why is it only there? And why does the texture of this hair vary so wildly across the human species today? Your body is a living archive. Every strand on your head is a physical record of ancient survival. For millions of years, your ancestors walked a precarious line. They balanced constantly between freezing in the dark and boiling in the light. You might think hair is just an aesthetic feature today. You spend hours washing it. You spend money styling it. You cut it to follow trends. But for the earliest humans, hair was not fashion. Hair was a matter of life and death. How did your ancestors survive the brutal climate of the Pleistocene epoch? To understand your hair, you must understand your skin. Imagine the transition from the dense, shaded forests. Your ancient relatives lived among the trees. They were covered in thick fur. It protected them from scratches. It kept them warm at night. But the climate began to change. The forests shrank. The vast, open expanse of the African savanna opened up before them. Your ancestors stepped out of the shadows. They moved into the blinding light. They began to walk upright on two legs. This was a radical shift in anatomy. This bipedal posture was a thermal game changer. By standing up, you exposed far less of your body surface area to the direct overhead sun. A quadruped takes the full force of the midday radiation on its broad back. You, standing tall, only catch it on your shoulders and the crown of your head. This gave you a slight, crucial advantage. But walking long distances generated massive amounts of internal friction and body heat. Hunting required endurance. Foraging required constant movement. Evolutionary biologist Daniel Lieberman has spent his career studying how the human body adapted for endurance running. His research shows that early humans became the greatest marathon runners on Earth. You could not outsprint a cheetah. You could not overpower a lion. But you could outlast them. You could track a kudu for hours under the midday sun until the animal simply collapsed from heat exhaustion. How did you do this? How could you run under the glaring sun without your brain cooking inside your skull? Your body had to undergo a radical, permanent transformation. You lost your thick coat of primate fur. It did not happen overnight. It was a slow, brutal process of natural selection. Those with less fur survived the heat better. They hunted longer. They fed their children. You traded your fur for millions of tiny, specialized eccrine sweat glands. These glands spread across your entire body. They turned your naked skin into a highly efficient evaporative cooling system. Water pulls heat away from the body as it turns to vapor. You became the sweatiest mammal on the planet. But exactly when did this happen? When did you lose your fur? Fossils cannot tell us. Hair and skin do not fossilize well in the African dirt. They rot away. To find the answer, scientists had to look at a parasite. Geneticist Mark Stonking from the Max Planck Institute looked at the DNA of human lice to understand this timeline. Lice are highly specialized creatures. They adapt perfectly to their specific environment. By examining the evolutionary split between human head lice and human pubic lice, his research revealed a startling date. Head lice live in the hair on your scalp. Pubic lice evolved to live in the coarser hair lower on your body. The genetic divergence between these two species tells us when the hair in between disappeared. Stonking discovered that your ancestors lost most of their body hair around 3 million years ago. Your body became naked. Your body became naked so you could sweat. Your body became naked so you could survive. But the top of your head remained covered. This is the great paradox of human hair. If being naked is so great for cooling, Why keep a thick patch of insulation exactly where the sun beats down the hardest? The top of your head takes the absolute worst of the solar radiation. Why not be completely bald? Leaving the head bald would expose the skin of the scalp to severe ultraviolet radiation. It would cause massive, direct solar heat gain into the skull. Your brain uses 20% of your body's energy. It generates massive heat on its own. It cannot handle external heat being pumped in from the sun. Your ancestors needed a shield. They needed a physical barrier that could block the harsh rays of the sun. But this barrier also had to allow the heavy sweat from the scalp to evaporate. If the hair trapped the sweat, you would overheat anyway. Enter tightly coiled hair. For a long time, modern science did not fully understand the mechanical genius of this specific hair type. It was often overlooked in thermal biology. But recent research has finally unlocked its brilliant secret. Does your hair type dictate how your body manages thermal stress? Biological anthropologist Tina Lasisi decided to test this exact question. She conducted groundbreaking research using a specialized thermal mannequin. She placed this mannequin in a highly controlled climate wind tunnel. She subjected it to hot, sunny conditions that mimicked the ancient African savanna. She tested different types of wigs on the mannequin. She tested straight hair. She tested moderately curly hair. She tested tightly coiled hair. She even tested a completely bald head. She measured exactly how much heat penetrated the scalp. The results were astonishing and definitive. All hair types reduce the amount of heat reaching the scalp compared to a bald head. Any hair is better than no hair in the direct sun. But tightly coiled hair was the absolute champion of thermoregulation. It was significantly more effective at blocking solar radiation. More importantly, it minimized heat retention. Coiled hair acts like a built-in, biological air conditioning system. The tight, springy curls do not lie flat against the skin. They grow outward. They twist and turn, creating a thick layer of airy, empty space above the scalp. This maximizes the physical distance between the hot, sun-baked surface of the hair canopy and the sensitive skin of your head. It breathes. It allows air to circulate. The sweat on your scalp evaporates easily, rising through the open structure of the curls. The heavy solar heat gets trapped in the outer, dead layers of the keratin. It never reaches your skin. It never reaches your brain. This hair allowed the massive human brain to grow even larger. It allowed you to function optimally without overheating in the most unforgiving environments. So let us recreate a day on that ancient savanna about 2 million years ago. You are a member of Homo erectus. You are tracking a wounded antelope across the dry, golden grass. The sun is at its zenith. It is a terrifying, life-giving orb in the sky. It beats down without mercy. The air shimmers with heat. Your bare, dark skin is slick with sweat. Every slight breeze catches the moisture on your arms and chest, cooling your core temperature instantly. But your head is shaded. It is protected by a dense, bouncy canopy of tightly coiled hair. You do not wear a hat. You do not need one. The sweat on your scalp turns to vapor. It drifts easily up through the airy curls. The punishing solar heat rests only on the very top of your hair. Your brain stays cool. Your vision stays sharp. Your focus is unbreakable. You outlast the antelope. You run it until its own biology fails. You bring food back to your tribe because your thermal regulation is vastly superior to almost any other mammal on Earth. For most of human history, everyone looked roughly the same in this regard. Everyone had dark skin. Everyone had tightly coiled hair. It was the original human hair type. It was the default setting for survival in equatorial Africa. But human history is not a static picture. Human history is a relentless story of movement. Around 70,000 years ago, the climate shifted again. Populations expanded. Resources grew scarce. Some of your ancestors began a great migration. They walked out of the African continent. They crossed land bridges. They moved into the Middle East. They walked into the deep forests of Europe. They walked across the vast, howling steppes of Asia. They pushed into environments where the sun was no longer a brutal enemy. They moved into latitudes where the sun was weak, distant, and cold. The seasons changed drastically. The rules of survival completely flipped. The danger was no longer overheating on a hunt. The new enemy was the freezing winter. The enemy was frostbite. The enemy was hypothermia. How does your body adapt when the sun becomes a desperately scarce resource? In these high northern latitudes, the brilliant thermal shield of coiled hair was no longer a massive advantage. In fact, it might have become a biological liability. Anthropologist Nina Jablonski has spent decades mapping how human skin and hair evolved in direct response to ultraviolet radiation. Her work is foundational to understanding human diversity. Near the equator, you need heavy melanin to protect your DNA from UV destruction. But as your ancestors moved north, the sunlight grew incredibly weak. UV radiation is not entirely bad. You need a small amount of it to penetrate your skin. You need it to synthesize vitamin D. Vitamin D is not a luxury. It is a critical hormone. It is crucial for bone health. Without it, children develop rickets. Their bones bend and break. It is vital for immune function. In regions with low sunlight, your ancestors needed to absorb as much of that precious, weak UV radiation as possible. Dark skin blocked too much of it. So, genetic mutations that caused lighter skin were heavily favored by natural selection. Hair evolved alongside skin. Tightly coiled hair blocks light perfectly. But straight, lighter hair allows more of that weak northern sunlight to penetrate down to the scalp. Every tiny bit of vitamin D synthesis mattered during a long ice age winter. Furthermore, straight hair behaves differently in the cold. It does not grow up and outward. It lies flat. It drapes heavily against the neck and over the ears. It traps a thin, still layer of warm air very close to the body. It acts like a natural scarf. It helps to retain physical heat in freezing temperatures. The airy, breathable structure of coiled hair, so perfect for the savanna, would allow too much precious body heat to escape in the frozen tundra. The environment was acting as a ruthless sculptor. It was chiseling away at the human form, altering the proteins emerging from your very follicles. Your ancestors who migrated deep into East Asia faced even more extreme conditions. They encountered brutal, high-altitude cold and fierce winds. Here, another unique, isolated mutation emerged. Geneticists studying ancient DNA have identified a specific genetic variant known as the EDR gene. This mutation caused a cascade of physical changes. It altered the shape of the teeth. It increased the number of sweat glands. And it drastically changed the hair. Because of this gene, East Asian hair became significantly thicker, straighter, and faster growing than hair anywhere else on Earth. The individual hair shaft actually increased in diameter. This was not a random, meaningless accident. The thicker, cylindrical shaft of East Asian hair is highly efficient at retaining physical heat. It is incredibly strong. It resists physical damage and breakage in extreme, freezing weather. It provides a heavy, dense layer of thermal insulation for the head and neck. The climate reshaped your ancestors completely. Every texture, every wave, every tight curl, every heavy straight strand is a geographical map. Your hair is a living record of where your ancestors walked. It tells the story of what they had to endure to keep their brains functioning and their blood flowing. Is your hair a reflection of the punishing equatorial sun, or is it a reflection of the blinding, freezing snow? The biology behind this diversity is breathtakingly simple, yet microscopic. It all comes down to the shape of the tiny follicle buried in your skin. Beneath the surface of your scalp, your hair grows out of these tiny pits. The shape of this follicle dictates everything. It acts like an extrusion mold in a factory. If the follicle is perfectly round, symmetrical, and sits vertically in the skin, it produces a perfectly cylindrical hair shaft. This hair will grow straight down. It will be straight hair. But if the follicle is asymmetrical, if it is shaped like an oval or an ellipse, and if it sits at a curve in the skin, the keratin proteins pack unevenly as they are pushed out. One side of the hair shaft dries and hardens faster than the other. This uneven tension causes the hair to bend. It causes it to twist upon itself as it emerges. This produces curly, wavy, or tightly coiled hair. This microscopic biological machinery is a direct, unbroken legacy of prehistoric climate change. The shape of that tiny pore in your skin was determined by the sun and the ice hundreds of thousands of years ago. The irony of modern life is profound. Today, you might stand in a brightly lit bathroom and use chemical straighteners. You might use scalding flat irons to flatten the coils your ancestors needed to survive the heat. Or you might use curling irons and perms to add texture to the straight hair your ancestors evolved to survive the frost. You spend vast amounts of money and time fighting the very adaptations that kept your bloodline alive. Agriculture and modern civilization completely insulated you from the brutal realities of nature. You no longer track animals for days. You do not sleep on the freezing ground. You live in climate-controlled environments. You have air conditioning in the summer. You have central heating in the winter. You wear hats. You wear hoods. You have forgotten the ancient, desperate purpose of your own biology. Your hair is now treated entirely as a fashion statement. It is stripped of its evolutionary dignity. It is judged by cultural standards that have nothing to do with survival. People face discrimination based on the shape of their follicles. Society assigns moral or professional value to how closely keratin proteins pack together. It is a profound misunderstanding of human history. But beneath the styling gels, beneath the dyes, beneath the societal expectations, the ancient mechanics remain perfectly intact. The genetics do not care about fashion. The DNA remembers the savanna. The DNA remembers the Ice Age. You carry the history of human survival on your head. You look in the mirror tomorrow morning. You run a comb or your fingers through your hair. Look closely. You are not just looking at dead keratin cells waiting to be styled. You are touching an evolutionary masterpiece. You are feeling the biological armor that allowed a fragile, naked ape to conquer every climate on the globe. You are preparing for a long day.